Before now, we have tried to look at why the essence of concept of programming languages. I will give you about 5 reasons why a computing expert should be exposed to the concept of programming languages. From there, we went ahead to look at the general language evaluation criteria, where we discussed readability, writability, reliability, and costs. Other costs, we talked about learning costs, implementation costs, deployment costs, and even market share. So, today, we'll be looking at programming language representation. Formal representation of what? Of programming languages. Before we continue, I may entertain 1 or 2 questions based on what we have learned so far. Any question? Any confusion? So I want to assume that, therefore, that we all understand what we are saying. Now, you were asked to ensure you subscribe to the YouTube video. Some of you are thinking that you want to help me. Last time we graduated 210 students, and that was not even up to 55% of those that are the number of students in the class. So if 55% only could graduate, that shows the failure rate is what? Is high. And the Senate complained about it. And this is one of the means we have devised to give you lectures and preserve those lectures so that instead of you playing or listening to skits, online nonsense, you can use the same time to be listening to what is of value to you. When you pass signals through your brain regularly, it will stick. Are you okay? So, formal representation of programming languages. You know, I've told you that there are 3 aspects of programming languages: syntax, semantics, and pragmatics. And you can see that the pragmatics has to do with real life implementation and usage. But critically, when you are being exposed to programming languages, you are always exposed to the syntax and semantics. The pragmatics is what you get by experience exposure. Is that okay? And if you like, by heuristics. Some of us are written programs, we just tap to wake up, and when we wake up, we develop those applications even before we start studying them. That's heuristics. It cannot be explained. People call it witchcraft, but whites may call it talent. Is that okay? And if you have such talent, make sure you develop it. Is that okay? It will make you a great problem solver. Now, why do we need to formally represent programming languages? Why? There are 3 stakeholders, 3 basic stakeholders of programming languages. Why we need to formally represent them. The first set of persons are the evaluators. Then the second set of persons are the implementers. And the third set, the programmers, which we refer to as the users. But the users in this case are what? Because the users of programming languages are what? Are the programmers. Programming language need to be formally specified to enable the evaluators of the language understand the language and even have a feel of the language, experiment with the language even before it is launched. Have a feel and experiment with the language even before it is what? Launched. I think Sebastian referred to it as initial evaluators. It doesn't even need to be the initial evaluator. Before it is launched, those are the initial evaluators. But if you want to really examine or evaluate the programming language, it is not those textbooks that you see that we look at. It is the representation, the formal representation of those programming language design that we will look at. Are you okay? That will enable us to evaluate it properly. Evaluators. Then the next set of people, is this thing working? The next set of people are the implementers. The implementers are those that write compilers and translators. Are you okay? Because you'll be wondering if the programming language is designed or just came into existence, how come there is a ready compiler, a ready interpreter for it? The implementers will have to look at the representation, the formal representation or description of that programming language, and that mimic the description and ensure that the compilers or the translators are translating as they are represented, as they are defined. Otherwise, there will be no relationship between the programming language and the translator. Are you okay? Then finally, the programmers. You may say, but that is the role of textbooks now. Textbooks will play that role. A lecturer will teach me, or a tutor somewhere will teach you. No, I will watch YouTube to learn how to program in that language. Hey, listen, you have not asked yourself, the first person to write the textbook, the first person to come out with how to use the programming language, what did that first person study? The best resource for a programming language is still the manual. Is that okay? The language manual is the best resource. So those of you that want to become gurus in programming language, or a particular programming language, look for the what? The programming language manual. It is the programming language manual is where you have representations, formal representation of that programming language. Are we okay? Are we okay? So what we have are textbooks. Textbooks are trying to break down the manual so that laymen can use it and understand. Are we okay? Because ordinarily, you may say, we should specify or represent the programming language using natural language. There are disadvantages why we don't use natural language to represent programming language. One disadvantage, it may be, natural language may be too verbose. There may be what? Not maybe. Programming language are usually too verbose. Natural language are usually what? Too verbose. Are we okay? Yes. They are usually too verbose. Natural language. You may ask me, why are we using formal representation and not just your English language or any other natural language? I am saying that natural language may be too what? Verbose. So the document for a programming language, if it is a natural language, will be too bulky. Are you okay? Will be too what? Bulky. Two, programming languages are are characterized by some form of ambiguity. They are characterized by some form of ambiguity. You know, where it is possible to assign possibly more than one meaning to a particular language component, or several language components having the same word meaning. In computing, we refer to it as issues of polysemy and synonymy. Polysemy and synonymy. Are you okay? I don't know, check the spelling. No? Synonyms. So let me clean it since they are recording it. Polysemy and what? Synonymy. Are you okay? Are you okay? They are usually characterized, natural language is usually characterized by those features. Situation where one thing has several meanings, it now depends on the context in which you use it, or many things having the same meaning. Are you okay? So, and we know we told you that a computer is what? A dunce. Is that also? Computer is what? So any form of ambiguity will not be what? It's not usually tolerated. And finally, why it is not good to use natural language, they are not usually amenable to computer manipulation. Natural languages are not usually easily amenable. Please add that word easily. They are not usually easily amenable to computer manipulation. They are not easily amenable to computer manipulation. Are you okay? So we have to use what? A formal representation. We have to use a formal what? Representation. Now, let us start with syntax. I told you before now that syntax simply means the structure. Is that not so? The structure of what? Programming language. Is that not so? What we mean by the structure, we're talking about, when we are giving you course content, if you see the way I gave you, I say variable, expression, statement. Is that not how I was giving to you? You should know when we get a variable that even a variable is what? When you get an expression, you know that a variable is an expression. A variable is what? An expression. So the basic components of what when we're talking about syntax are expression, statements, and your noise, program what? Program units. Another program unit. So syntax describes the form of these language structures, expression, statements, and program what? Units. So we're talking about syntax, we're talking about the form of the expression of the programming language, the form of the statement in the programming language, the form of the program units in the programming language. To organize your practicals, you see the sheet you are signing. Each sheet contains 30 names, and those 30 names makes a group. Is that okay? The timetable will soon be out so that each group will be entering the lab to expose themselves to some practicals. Now we are talking about syntax, expression, statements, and program what? Units. The form in which they are. Are you okay? Now they have to be represented. They have to be represented. There are two formal ways to represent syntax in programming languages. Two formal ways. One is the use of context-free grammar. Context what? Free grammar. CFG. And sometimes regular grammar too, but they are together, but basically context-free grammar. Regular grammar is used to represent the tokens. And the equivalent, they are almost the same. The Bacchus lower form. Anywhere you say it in the word BNF, it's that we are referring to. And its extension, which we refer to as the extended BNF, the extended BNF, that is EBNF. We will be taking a look at those two today and more. Now, in formal language, a course you have taken in your 300 level, you were sufficiently exposed to the Chomsky hierarchy, where you know about the context-free grammar, the regular grammar, context-sensitive grammar, and all those stuff. You see, that is the reason, is to remove that part from this course, that you study that course. Are we okay? Are we okay? Whether programming language or natural language, a language is simply a concatenation, a collection of symbols from a set called alphabets. Are we okay? Governed by certain rules you are referred to as grammar. Are we okay? So whether programming language or natural language, but programming languages are more streamlined compared to what? Natural language. Even the simplest or weakest natural language is more sophisticated even than the most sophisticated programming language. Are you okay? So we'll be taking a look at whether context-free grammar, Bacchus-Naur form, they are both equivalent. They are both what? The only thing is that, you know, as you were taught in 300 level, you were told that they use capital letter for no terminal. Is it not so? And use small letter to represent terminals. And use the Arabic, is it Arabic now? No. Your alpha, beta, and all the stuff to represent sentential form. I hope you know what is sentential form now. You know. You know. You do formal language and you don't know what is a sentential form. Therefore, we will go back and follow of you in the course. Yes. How can you say you don't know what is a sentential form? A string is said to be in sentential form if it is still a mix of terminal and what? Non-terminal. Or it has all not become purely terminal. When all the string become purely terminal, we now say it is what? A sentence or a word. But when it is still not there yet, we say even if it is all non-terminal, we say it is a sentential form. You know, you want to just play me, or want to see whether I know it, or so to be a record that you don't know, you know. It's okay. But in Bacchus-Naur form, the terminal, which we refer to as the abstraction, is usually in angular brackets. They are in what? While others, terminals like operators, identifiers, literals are not in angular brackets. Are you okay? That's just the difference. The difference between this and this is the use of what? Angular bracket. Otherwise, the arrow is still there for production. You know, generally, formal representation says that a production, you know, a grammar is a collection. You know, you were told that a grammar is 4 tuple, But one of the important and most important characteristics of a grammar is the production rule. Is that not so? Good. Where production is having the left hand side and the what? The right hand side. Because no form says that the left hand side, the left hand side will always be reduced to the right hand side. So basically, Bacchus-Noah form is of this form. Basically, Bacchus-Noah form is of what? That form. Bacchus-Noah form is of this form. Left hand side produces right hand side. Is that okay? Where this right hand side may not just be, can be this and more. This is the basic description of Bacchus-Noah form. Just take note, it has two sides. The left hand side and the right hand side. Is that okay? The left hand side is what we want to reduce. And when you now reduce it, you have the right hand side. So the right hand side describes the what? The left hand side. For example, my pet language Java, for a simple assignment statement, where you will say maybe var is equal to var1 is equal to var what? var2. Is that an assignment statement? Is it? Yeah. Good. I will not write it like this in Bacchus-Noah form. So this is an assignment statement now, and this is its representation in Bacchus-Noah form. But if I have another one like var1 equal to s plus 2, I'm going to write it as var1 produces s plus what? 2. This plus and these two are literals, so they are not in angular brackets. Anything in angular bracket need to be further reduced to a terminal. Are we okay? To a terminal. As I will tell, as I told, I think last time as well, I will say, okay, that means the set, that means this thing is pregnant. The one that is in angular bracket is what? Pregnant. It is meant to be what? Simplified further. It is meant to be simplified further. Are you okay? It's just to start it simple. Somebody, are you okay? What are you not okay about? S is a variable. It's not known. Are you okay? Maybe S is carrying something. We don't know yet. So because of that, it has to be in angular bracket. But this is a literal. This is an identifier. This is of there. You know, what I have to tell you is that I have not entered the Bacchus-Noah form yet. I'm only preparing you. Are we okay? If we cannot put S in bracket, why do you put var in bracket? So don't take your mind off. So this var, I'm saying this is var, I'm saying this is S, but this is already what? No. Are we okay? Are we okay? I know what you are saying. Yes.
I don't have like var1 equals to s plus y, then put s and y on.
The stage where we are now, you put them what? in brackets. Are we okay? Are we okay? Now we'll give you the general rule of Bacchus-Noah form. We'll give you the general rule of Bacchus-Noah form. 1. Rule 1. Abstracts are kept in angular brackets. Why abstracts? Yes, abstracts are kept in angular brackets. An example of abstracts are those things like in English language, you have a verb, adverb, pronoun, noun. Those are what we refer to as what? Abstracts. Are you okay? Good. Abstracts are kept in angular brackets. In what? Angular brackets. 2. All others, including identifiers, literals, and operators. Not even special symbols, not just operators, but special symbols. And wheres. Special symbol and wheres are all left alone. Because those identifiers, literals, special symbols, and special wheres are seen as terminals. Are they not? Are they not? Good. 3. We use arrow, directed arrow, to connect the left hand side with the what? The right hand side. 4. We use the bar to represent all. Alternate, all. Abstract in angular brackets. Is this abstract referred to as what? Non-terminal. And these others are the what? They are the what? They are determinants. That is why that man was confused when I saw me put S in angular bracket. You see, when you are training a child or bringing you up to, you first of all make his understanding. When his understanding is clear, you now expose everything clearly. Are you okay? So I was telling you that var. Let us assume that var is abstraction in angular bracket. So if var is in angular bracket, S should be in angular bracket. But in the real form of Bacchus-Noah form, it is the abstracts that will keep in angular bracket. Like in English language, in programming language, those abstracts are what we refer to as the terminal, while the others are the terminals. So in English language now, it is those. Listen, all these ones, everything used to form these ones are from a set of symbols called alphabets for the programming language. But the abstracts are not usually formed from a set of symbols, but they need to be broken what? Further. We use the word reduce. They need to be reduced. You did compiler. Now we will take an example and then we move ahead. Okay, so there are two basic symbols. Okay, finally, I told you the angular brackets. Okay, we have described that. Angular bracket is to hold what? Is to hold abstract. Direction. bar for alternate or. Are you okay? Are you okay? Now we take a description now. Assuming that in every language there is usually a special abstract or a special abstraction called the start symbol. Called what? You are used to it in formal language already now. You know the start symbol. It's a special non-terminal. And also, the same way we have here in Bacchusnian form, that one too. A common example is what we have in your assuming you have assuming you have E produces E plus T. E minus T and even E. This is context-free grammar now, because in context-free grammar, the L value, the left-hand side must have one, must be made up of one and only one. You know so, but the right-hand side can be any number. So now, this is a good example of a production. True or false? Good. Now, in Bacchusnian form now, we can represent this as expression produces expression plus term or expression minus term. I may even say, okay, there's no space there. I can put the all here, I can put it there, and I will say what? Expression. So, boss, you see when I was writing E as variable then, I was seeing it as what? As an abstract. Is that okay? Do you understand now? But we have told you what should be abstract now. A good guide is English language. Always your verb, adverb, pronoun. All those things are what? They are what? They are abstracts. Are you okay? They are what? Abstract. Then every other thing that they see from the alphabet combined, all those ones are that they used to form the sentence. They are the terminal. You can quickly go and revise your formal language again. So now this is it in Bacchusnian form now. But when we are testing you in the exam, we don't usually give you a grammar in context-free grammar. We don't give you grammar in context-free grammar, a progressions in context-free grammar, and ask you to convert it to Bacchusnian form. Because if you see this and this, they are saying the same thing. Is it not so? That's why you say that context-free grammar and Bacchusnian form are what? Equivalent. Only that because of the angular brackets describing some things, it's not matching processable. For example, if I put S, like he was complaining, he saw S as variable over 1. If I put an angular bracket in Bacchusnian form, it means what? It's an abstraction. That means to be what? Reduced. But if it is a context-free grammar, it will be confusing. Because even this now, although it means expression, it can be confusing with another identifier. True or false? Good. So that is weird. And it was almost the same time that came into bill. Yeah, the same time. The same time. So you have see E now. It's like a variable, Abi. But this E is an abstract. It's an expression. Is that not so? Is it not so? You can have a statement. So it is that confusion that you entered, you saw when I was using S and everything as an abstraction then. That is why we prefer Bacchusnian form. Once it is angular bracket, you know that it must also come and appear on the left to be reduced. It must. Anything in angular bracket must have a reduction, must have a right hand side equivalent until you get to a terminal. Are you okay? Like this terminal is not complete yet. With terminal will have to be supposed to be what? Will be reduced. But it's for teaching sake. Now this is Bacchusnal form. So the exam we give to you is not always to say you should convert CFG to BNF. But our exam is usually to say you should convert BNF to EBNF and EBNF to BNF. Are we okay? Are we okay? We know we have introduced you to context-free grammar in formal language. Some of you may not be so good in the course, but some of you got A in the course. So, if you are not too good in the course, you can go and brush up the course. I think the person that taught you was Obasoa. The same Obasoa taught me many years ago. And I got A in the course. And he's very good in that course. Even the question that I did the other year, when we were discussing, he said he did not even teach, he's not able to teach, he's getting old now, so he's not able to teach you people up to the depth he was teaching us then. In the 6-7 weeks, we almost through, we now enter Turing machine. Which people, I'm sure some of you did not even do Turing machine. I so love the course that I even have to do the course in the at MSc. It opens your brain. Because the computer is actually automaton. The computer, this complex computer is what? It's an automaton. Well, let's leave there and let's move ahead. And that is the breakthrough that you are all enjoying the computing today. If it was not possible to formalize language, today computer science will not have been. Because it is the ability to get a language for the machine that is making IT to boom. True of us? Yeah. So let's go ahead. Now, what is the difference between BNF and EBNF? We'll discuss it now. But take note, BNF, EBNF, they are what we refer to as meta-languages. A language that is used to describe another language. And you can begin to see where your markup language came from. You are seeing it now, the use of angular brackets. Now, there are three, wait now, Bacchusnal form was extended, not because it was not good enough, but because it was observed that the aim of formal description is for it to be precise, and as precise and as concise as what possible. Is that okay? And the extended Bacchusnal form came to strengthen BNF by bringing in concision and making it easier to write and then to read. Because when you are talking about a whole programming language, specifying it in using Bacchusnal form, remember we condemned natural language, say it to be too verbose, isn't it so? So we were not seeing some things about BNF that could be written in a shorter in a more concise way. Are we okay? That is what EBNF achieved. Trying to make BNF to be more concise. And when it's not easy to write, definitely it will not be easier to to read. Are we okay? Good. Now, what are there are three basic introductions, three basic things that EBNF used to extend BNF. Number one, we call it optionality. It brought in an instrument to optionality. I don't know how to call it now, but write it optionality. By introducing square brackets. It brought in a mechanism, introduced a mechanism to handle what? Optionality. Are you okay? Parts of BNF that are optional, instead of, if it is optional now, they will write it twice. But we will just put it once and tell that this one is what? Optional. For example, in if statement, we will tell you that if statement if condition, is it also statement S statement, is it not true? Is it not true? This is how it is specified now. But if it's to, so this is if statement now, or if condition, just statement. Now it's writing it as two. EBNF will say if statement is just, if it is EBNF, because of the video, if condition statement S statement. Now you can see that the difference between this and this now is writing the same thing, but instead of using two lines now, it's using only what? One line. By saying that the S part of it is what? Optional. It's saying the S part of it is what? Optional. So instead of using two lines, each statement will give us if, condition, statement, S. I think S should not be in brackets. Even the condition here, it's a statement. I hope you know. We can say expression. Let's put expression there. Let's put expression here. The S doesn't need to be, because the S is not an abstraction. It's just like the if. Then let's put expression here. Hey, your noise. Hello, you are not. You are not near where the camera is. You are making noise like this thing. Camera, if anybody make noise, video is face, so that the whole world will know that he's a noise maker, and his future employer will see him as a noise maker. Now, look at it. I don't make some corrections now. But if statement is if expression statement S statement, or if expression statement. You know what we know it to be? Now, you cannot see for me that the S statement, or we call it the S, we should see it as the S phrase is optional. Is it not so? So EBNF will not write on one line. If statement. If statement. See the EBNF now. If statement is if expression statement. S statement. But the S statement is now in what? It's in square bracket, telling you that it's what? Optional. Are we okay? And instead of writing this one in two lines now, it has now been written in what? In one line. This is one feature of EBNF. So you can see that if the document would have taken, say, 30 pages, a BNF will take 30 pages, and EBNF can take about 20 pages. And the readability is even more, it's enhanced. It's enhanced. Because this one is easier to understand if you know the meaning of this square bracket, then this one is 2. Are we okay? Are we okay? So the main aim, even as stated by Sylvester of Colorado University, for EBNF is to enhance writability and readability. I'm only adding that it will help to reduce textual space or volume of documentation. Concision. Concision. It's more concise. EBNF is more what? Concise. And when something is not concise and precise, definitely Semester is right. It will not be easier to read and easier to write. Are you okay? Because we will ask you in the exam, what are the advantages of EBNF over BNF? And what are also the disadvantages? I will give it to you later. But now, that is one extension. Second extension is iteration. We brought in iteration using curly braces. When anything is a curly braces, it means it can be repeated 0 or more times. Remember, it's iteration now. Iteration is 0 or more times. When we get to statements, you get to know the meaning of all those things more. So, if there's anything that you need to repeat, for example, now if we're talking about a program header, where you have okay, you know that a program is simply a collection of statements. True of us? I hope you agree. Good. Now, how will you specify it now in formal representation? That a program will give you collection of statements. How many statements? Do we know? So let's say program. Give us statement. Okay. At least there should be one statement. I say at least there should be one statement. If this is a program, are you seeing it now with EBNF? Is that also? But how will BNF specify it before? BNF would have said, what did you comment? Prof. Yep, what is that? Oh, booklets. Is it not booklets? Let me come back. Who will come back correctly now? You should meet me for a level class. Yes. I'm supposed to make arrangement for this thing before now. I don't even know whether there is booklet. Although we have provision in BNF to say program will give you statement I think it's 2 ellipse. But it's not standard. Ellipse, you make use of ellipses. Maybe if you are saying 1, 2, list to maybe 9. It makes use of what? Ellipses. 1, 2, in that order, dot to what? To 9. Are you okay? So this one is clearer. That you can have, you say you have at least one statement. Good. There are even some versions of EBNF that will say, oh, that's what I was about to write there. Don't just put this one, I don't write plus here. When you can decorate the curly braces with cardinality, a number to specify the number of times. Say 0 or more. This one is saying 1 or more. Plus means 1 or more. When I put star, it means so. But if I leave it like that, it means what? 0 or more. If I put plus, it means what? If I put 3, it means what? No, 1 to 3. If I put star, 0 or more. But I don't to put star because on its own it's already saying 0 or more. If I put plus, it means what? Why if I put n, 0 to n? It's going to end in n. So I'm telling you the number of what? Number of iteration.
That means 3 plus is 3 or more. No, assuming you want to say 2 or more.
There's no 2 or more. You never start from 0 or 1. Is that okay? It is a language. It has its rules. So I'm trying to give you. This is even a version. A version. Not all versions support the adding of numbers to tell you the number of times. Are you okay? No, n means n times. So it will be 1 to n, please. When it's left as default is 0 or more. When you now put plus there, 1 or more. When you put n, it's specifying the number of time. If it is 10 times, that thing should appear 10 times. Are we okay? Are we okay?
Yes, sir.
That is iteration. Then the other one is what we refer to as alternation. Many books will just say alternate. Alternate is a collection of symbol using inside bracket 1 or more bar inside parentheses. 1 or more bars inside parentheses. So what is showing is what we refer to as it can only do 1 out of what it describes. It can only do what? 1. Assuming I have something like this. S. Okay, let me do this rubbish. Plus or minus or star or it cannot do more than 1 at any time. Are you okay? It can only do 1 at a time. So although they call it alternate, I wonder why they should call it alternate. I think it should be better be called exclusion. You understand the exclusion? That is because exclusion says that if it's taking 1, you are excluding the others. Or something is mutually exclusive. Because everything here is used to describe mutually exclusive options that are mutually exclusive. Thank you very much. That means you can only do one from among them at a time. Is that okay? So these are the 3 extensions that EBNF introduced to what? To BNF. Are we okay? These are the 3 extensions. So we'll just take an example of BNF now, convert it to what? EBNF. When you go home, check the textbook and online, get many EBNF as you can, spend about 2 or 3 hours, convert it to EBNF, and from EBNF, convert it back to BNF, because you will meet it on the exam day. So let me give a good example now, so that we can now go into semantics. There's a common example Sylvester, let me clean the board well. Classroom, come to the office and take duster, please. I always forget because this class is first period. You people should be happy. It's the VC that is making me to do this thing for you. Yeah, because when we approved the result at that time, they complained about performance too poor, and I promised that we will teach you, we will devise a way to make you know it better. So I wish, I'm just leading by example. Other lecturers will follow suit. But I know that you can only allow your recording if you are very comfortable because so but with time we'll be encouraging them to do so. I can even do live streaming, I don't have problem. Now listen now, we look at this example. Then some instead of this arrow, some version, even the standard EBNF uses colon. I have seen some programming language manual that uses double colon. Are we okay? Yes. Instead of what? Arrow. And the reasons are not is because in the computer this arrow is not easily, it's not in many keyboards. So there's some use colon, that's why I use this double colon to specify to represent this arrow. So if you see it like that, don't bother, it means the same thing. You are making noise, oh. If you make noise again, I will cry, oh. Why don't you come and say that you are knocking? Give it to Ame. Let me collect the booklet and give it to Ame. Hey, your noise is too much. You are not disgracing yourself. I will send the video to VCO. So that they will know that you people are noise. Don't mind that you are not ashamed. Shameless children. Your mates in the north are already father of 3-4 children, father of 2-3 wives. Now look at this. Hey, your noise. Your noise. You are even disgracing yourself by making noise. The class is under recording and you are making noise. Please, the employer, listen to them. Oh, they are making noise. Camera, please be join their face if they are making noise. So that when you now apply to Manchester University, the admission officer will say, oh, you are making noise in class. You will say no. It's an interactive class. No, you don't need to make noise. You will say no. You will say, I have evidence. I have evidence. You will not crop the video and show you. Your teacher was teaching and you were making noise. Now let's be serious. Because we have many things to cover. Now the equivalent EBNF will be, I know you will shout it now. So in your exam, if I don't use arrow, don't be surprised. Is that okay? I've already told you that there are versions. This is the EBNF equivalent of this. You say? There's nothing you can do to this. So this is the EBNF equivalent of this BNF. I use this example because it's one of the most confusing examples. You see that we play with something there. Now look at it. If you check here, expression can become 10. Is it not so? It can be expression plus 10, it can be expression minus 10. So I now say, okay, middle power. Expression is 10. That one is sure. Is that not so? Plus or minus 10. You will not be asking me, what of this expression here? But expression is 10. Are you seeing what I'm saying now? Yes. Come again. Expression is 10. So am I wrong? Where all this one can happen 0 or more times, expression is what? 10. True or false? You know I did not go to school. But you are not saying, how can I represent this? This is it now, expression plus 10. Is it not it? Because expression is 10. It will not be easy for us to represent. Then 10. You may say God's power. Why not use this symbol? Listen now. This one cannot be more than. This one is optional. But remember, there are two things inside. If it appears, no, it may not appear. Is it not so? But if it appears, there are still two things that should happen. So it should be able to happen more than once. And this one cannot happen more than once. Are you seeing what I'm saying? Yes, did I go to school? Because your mind will say, put that one. You don't forget that there is already inside two things. That means it should go a minimum of what? Twice. The first time, it will take addition or subtraction. Second time, go. So You cannot use, it is this you will use to describe it. Do you get it clearly now? Sometimes I tell people, I prefer to even be using this for safety, because that one is 0 or 1 time. Also, what is one is 0 or more time. That is, the square bracket is inside the curly bracket. It will be hard for you to be failed or to get 0 with the mark if you use square bracket. It includes 0 or 1. If it is 0 or 1, well, you are not safe. Is that not so? Yeah, you are seeing what I'm saying now. Except it's a rule that it should be 0 or 1. Because if you look at programming language, the if statement, you can have S many times. True or false? So the right for you to specify S is not that the S is optional, but rather the S can be 0 or more. Good. That is it. So now, in case you are also giving some things in EBNF, you should also be able to convert it to what? BNF. But relax. The word now probably uses EBNF, because you can see that even if in most programming language now, in most description, they'll put this one on one line, this one on one line, this one on one line. That's how many lines? But this one will be on one line. Because when you want to put all, like will be on 2 lines. When you want to put all. Because some version of EBNF or BNF don't use this bar. They only put 1 on the line, then they will put the arrow, every other thing will appear on the next line till it's finished. So remember that each line is showing alternative until you see the next arrow is start afresh again. You understand now? So for EBNF now, because there is no all here, everything will be on one line. So you see, it will be more concise. Is that not so? Yes. Therefore, it will be readable and writable. Are we okay? Are we okay? So give a hand of applause to Sylvester. Yes, sir. He explained it very well. As I said, you may not use this bar, but you just ensure that you put it on the next line. When it goes to the next line and we don't see arrow, we know that it's still all to die. Is that okay? Yes, sir. Is that okay? Now we not go to, all we just do now is how to, we just introduce you to specifying programming language syntax. Is that okay? The Bacchus-Noah form and its extension, extended Bacchus-Noah form. So that you can read programming language manual. Programming language manual are usually specified with this. Then with what we are going to later, which is the semantic representation, where we have the operational semantics, where we have the axiomatic semantics, and the denotational semantics. Are you okay with this? So semantic representation. Yes. Okay, question time before we enter semantic representation.
Is there any case where, because you said expression is equal to 10. So
it's what you were given.
Okay, sir. And from the question, it is expression arrow, expression to.
No, don't say you did not come to. I did not teach you. Expression produces. Hello. Expression produces some programming, some version of EBNF uses equal to. Is that okay? It should be standard version uses equal to instead of arrow. Take note of that. That is just say like this. Is that okay? But the list. So expression produces expression plus time, or expression minus 10, or 10.
So if expression is not produce 10, can we see equate expression to text? So
No, how can you equate expression with text? If this one is not there, you just say expression is it not true? If no was not there, that is true now. So what's your problem? It's because the expression is equal to 10, you're not replacing it with what? 10. Are we okay? Are we okay? Yes. Huh? Yes.
You put it to expression in parentheses. Because parentheses have any meaning there.
That's how we are given now. This is what we were given now. But the parenthesis here is telling you that bracket, you know bracket, when we say expression, it can be in brackets. Like I was saying, x plus y. You know, when it is in parenthesis, you do it first. Is that not so? Is it not so? If you have parenthesis and there's no bar inside, it has no special meaning. Hello? You can have one or more bars, that I told you now. But if you have a parenthesis and there's no bar inside, it simply means the meaning is not from back, it's not from formal representation, backwards normal form or its extension. Are we okay? Are we okay? Mm-hmm. Any other question? Yes. The has to be giving you mic. I don't want to give you mic. Don't worry. Plus what? Plus or minus. You know, see me reading bar means all. This or this. Are we okay? Are you okay now? Are you okay now? You were sleeping when I was telling you that it's all. Or is it because of the fine girl that was sitting by you? It's affecting your rate of assimilation. Okay, let's go ahead. Can we go ahead now? So practice will make perfect. So we have a new GA now. Maybe if people are free, come and give people tutorial more to solve more problems. Is that okay? Yes. And last question, please. No, you cannot. This is telling you that some things in BNF cannot be reduced further. In EBNF. Are you okay? Are you seeing it now? We cannot reduce it further. There's nothing you can. There's nothing you can do. If there's nothing you can do, there's nothing you can do.
It says expression is either expression plus 10, expression minus 10, or 10. It's only going to be one thing. It's only going to be one thing.
It can be one of any. If you fall to one of any is correct.
Only one.
Yes.
For the EBNF, it says expression is 10 plus or minus 10, but then it's an iteration, so it will happen more than one time.
No, it can happen 0 times too.
It may never happen at all.
It may never happen at all. But we have not demonstrated that now. You see this problem? When, from my experience, I have known that students have that thought, and I imagined it for you, and I asked it and I answered it. You were not here, you were talking to that boy. And the boy has earring in his ear. Let's go to semantic representation. Though we have a generally accepted mechanism to represent syntax, there is no universally accepted mechanism for specifying semantics. I told you that syntax has to do with the form of expression, statement, or program unit, and semantics has to do with their meaning. Are we okay? Did that come before? Can you imagine? No, leave this camera. Yes, record it. Can you imagine? Luckily, you were all here. You were all here. I did not come before. I said I should come again. I cover myself with the blood of God. Cover myself with the blood of God. Yeah, I cover myself with the blood of God. In short, cover myself with Elala blood. Elala blood. All the blood. It's okay, let's go ahead. I was saying that syntax has to do with the form of the expression, the statement, and the program unit. While semantic has to do with the what? Meaning. As there's something for me to come again, sir, you should go and play the video when it's loaded. Thank you. So let's go ahead. But without wasting time, programming language semantics cannot be completely specified. We only specify some aspects of it. It cannot be completely specified. That is a problem we have. And when we achieve that, when man or humanity is able to achieve that, to completely and correctly specify semantics of programming language, then we may not even need to be building, we don't need to be testing program again whether it's correct. We will just know after you write the program that this program is correct. There will be no need for testing. It's because we cannot specifically specify programming language semantics that we still write program and then test it. Well, it's okay. Maybe some of you people that will bring that breakthrough are here.
Amen.
Now look at it. We have three mechanisms for specifying semantics of programming language. I don't want to waste time. We have operational semantics. We have denotational semantics. And we have axiomatic semantics. Operational semantics mimics the behavior. So it describes the behavior when the programming language expression, syntax, or program unit is executed on a real machine. Sorry, on a real or virtual machine. We use axiomatic semantics to describe the behavior of a program expression. I cannot say exactly the same with Gradocam. I'm telling you what I know. So, I'm an operational. Is that axiomatic? I'm an operational now. I said it's used to describe the behavior of a programming language expression, statement, or program unit on a real or virtual machine. On a real or virtual machine. It used to describe the way it will behave on a real or virtual machine. Usually virtual machine anyway. And it makes use of lower or low level programming language features to the means of a low level programming language features to describe a higher level programming language features. So operational semantics make use of what? Low level. I try to use it to describe what? A higher level. Its main aim is to remove the cosmetics and make you see the way it will actually execute in the computer. The main aim is to remove the cosmetics and make you see the way it will actually execute or behave on a real or virtual machine. And there lies the problem. And there lies the problem. You are still using a programming language to describe another programming language. Are you seeing it now? You are still using a programming language to describe another programming language. But, and therefore, it can only be used, operational semantics description can only be used to describe the various states of a program segment in execution. It can always be used to do what? Describe or tell the meaning of the various states of the program on execution. So what it does gives the meaning when it is what? Executing. You can see the word operational when it is executing. Just the what? The meaning of that program segment on what? On what? On execution. The various states. As it moves from one state to another, you can use operational semantic description to track those states. Are we okay? To track those states. While these operational semantics make use of low-level languages, denotational semantics make use of mathematics, and axiomatic semantics make use of logic, precisely predicate logic. Predicate logic. This one makes use of mathematics, this one makes use of predicate logic. Most times, the axiomatic semantic is used for proof of correctness. We will not go into it in detail, but in MSc, I teach it in detail, and I set questions from all these three things. But for O level, for BSc, we just want you to be aware. Is that okay? Denotational make use of mathematics, while this one make use of logic, predicate logic. Are we okay? But I will give you an example of operational semantics. In compiler, those of you that I taught compiler, you know that I taught you how to represent a program using a 3-address code. Is that not so? Is that not so? And that is a good example of operational semantics. You remove the cosmetics. So when you represent a program with 3-address code, for example, it will expose the way to behave on a real machine. That is a good example. So most times, what we demonstrate in operational semantics is for example, if you say a statement, for example, for I equal to 1, I less than j, I plus k equal to k plus s. Let me say statement now. Are we okay? That's a statement now, B. So in operational semantics, we can say, well, I equal to 1. Then I will now say If I is greater than or equal to J, should I do anything? I will go to out. Then I will now say K is equal to K plus what? S. I will now say I is equal to I plus 1. Then I will now say out. Then I will now say so before I say out, I will just say go to if. Then I say out. Out means stop. If. Hey, you are disturbing me. Why? Let me say if statement. If state. So I will not call here if state. So this is the operational semantics of this statement. So you know that the first thing it will do, it will say I equal to 1. Are you listening? So this is the operational semantics of this. So I'm going to give you some short code snippets, some statements, and I will ask you to give us the operational semantics. So this is operational semantics of this. It said I equal to 1. If I is greater than or equal to J, stop. Are you seeing it now? Don't do anything. Because you say I should be less than what? J. The reverse. Then if it's not out, that means it's in. Is it not so? Then you not do what you asked to do. Then you not increment. Then you not go to this place again. You not see how this one is describing the behavior of what? This. So it's telling me that this is how this statement will behave on what? A real or virtual machine. Where the virtual machine is me, now in this case, in my head. Now what I want you to say, you will see that, you will see some manual, they will not write it like this, it will not write statement here. Is it not so? Some manual will not do it like this. Here, it will write initialization. Let me tell you how the manual will draw it. Let me tell you how the manual will draw it. The manual will say 4. Initial. Is that not what they say? Initial what? This expression. Is that not so?
Yes.
Is it expression? Yes. This is also expression 1. Expression 2. Increment. But expression is decrement. Expression again. Expression what? 3. It will not say statement. Where this statement can be compound or simple statement. Are you seeing it now? Are you seeing it? They have another description for statement too, but look at this thing. He will not tell you, I may write it like this, I will do it 2 ways. Because you show them in any textbook, you will not be angry. He will say expression. 1. Maybe in. If expression what? 2. If it's a language that put it in brackets, like Java, you can put it in brackets. Are we okay? Are we okay? Yes, but we are not using low-level language, so let us leave it. If expression, you can leave it if you like. You can remove it if you like. If expression 2, go to what? Then we will not tell you statement. What does it say? Then we will not tell you expression what? Expression what? Expression 3. You will not say go to in. Go to what? In. You will not say out. So this is the operational semantics. So when you are learning the programming language, something like this. With this now, you'll be able to what? Understand. This is one reason why we taught you assembly language. You don't know why. We taught you assembly language. Listen, so that you can be able to reason in low level what? Language. So you can be able to reason in low level. So that when you see documents like this, even if it's not assembly language, that put things as low or very low, you will be able to understand. That is why in compiler introduce you to 3 address code, not just for compiler's sake, that you may be able to think in line in low level. Some textbook now, some manual will not write this thing as statement like this. Why some put this thing as this? You understand now? You understand now? Good. Do you understand? Telling you that this one or this one will be broken further. Hello? Good. Now, I will just say expression. Expression 1. Expression 2. Statement. Expression 3. So you see some diagram, any diagram like this. Sorry, this one should not be circle, it should be. I have given the operational semantics of this. I can write it out like this, I can put it as diagram. But this is the operational semantics of what? These statements. This is the operational semantics of this statement. This is in diagrammatic form, and this is a form of programming, that lower level programming language. Many people say they prefer this because this one speaks in flow charts, which every computer student is introduced to. Program flow chart, yes. And until you can represent statements and everything, so if you see manual, programming language manual, you see things like this and things like diagram. Forget about it to be final, it will be what, and that's what you just study to know. Are you okay? Are you okay? So denotational is complex. You have to do a lot of mathematics. It's only twice I have taught the denotational in MSc because they abandoned the question for me in the exam. But the first set, the Mosasari set, I think Mosasari will be coming to teach this course with you because he got A in that course. They did it. The next year when I did it, I don't know where the system is getting weaker. So I stopped teaching it because they are running away from me. But I now teach operational semantic and axiomatic. Even the axiomatic semantic I taught last now, there is still wahala. Big wahala. You say? No, for your level, no, it's not because it's your level we don't. But they are aware. But we will examine you in operational semantics. Because as a programmer, operational semantics will enable you to learn the programming language very well, particularly from the manual. Is that okay? So that's when you are confused about a part of a program you wrote, you will get the operational semantics. I'll give you a secret. When I went to Rwanda, I as a UN representing Nigeria in UN in Rwanda, they came with a program that written in a programming language I have never programmed in. Listen, and they said I should debug it. That they have been trying to debug it, they could not debug it. And they now give expatriate. I was not there as an expatriate. It's either I accept that I'm an expatriate or I deny my expatriate. So inside my AC when I was this thing, and I just laughed. Do you know how I debugged the program? I sat the person down. I was asking what is the meaning of this in this language, what is the meaning of this, and I was repeating the program in a personal form. And we saw where the error is. And that's how I debugged it. Yes. I tell you now, most of you that are programmers, when a code is complex, look at the area. That's why we are advising to be very modular. And you break your program to pieces so that you write more modular program. So that you know what the program, you can trace the program. Take each part, each component, get the operational form. You will know where you are missing it or where you are not missing it. Is that okay? It helps. And when I finish, hey, Nigerian man, Nigeria intelligent. They were saying I should not go safe. If it was now, I would have stayed. But it was 2005. And I've not gotten my PhD then. But the only thing I did is that is what angered me to do my PhD in a rush. But the money I made there, when my mates were coming to Nigeria with dollar, I came with 2 big books, bag of books. Why? I was not having a master card to buy things online then. Nigeria banking system has not developed like that. Even Rwanda was like that. But the white men that came from other countries like Canada, Switzerland, all those places were working together. I will give them dollar in cash, and they use their credit card to pay for the book. So I was gathering them. No thing that I will not see. And I will pay for ACM and Achupori library 3 years down. So when I came, that is sacrifice. So when I came, my family member thinking that I brought dollars. I showed them books. So when I got my PhD in 3 years, Nigeria people were not calling it as witchcraft. It's not witchcraft. I was having latest books, and I was exposed to the most powerful digital libraries at that time, ACM and Achupori library, which I paid. So when you learn from masters, you become a greater master. No, but it's true. If most of you here can be better than me, I have faith. Yes. My success is not what I teach you well. That's why when I teach, I motivate. My success is your success in the IT world. The more successful you are, that means I taught you very well. And the less successful you are means I failed you. Is that okay? But that is okay. That is for the operational semantics. Now, so I'm talking about forget about the types of operational semantics. For those are theory. Is that okay? Because we talk about the one we talk about now, that I discussed, is what we call the structural operational semantics. Because this is what I talk about. That's why it talks about structure. It's very close to syntax, structural operational semantics. Because you see now, you cannot be able to, though it's telling you about the structure more, it's helping to get the meaning. Yeah. So it's structural operational semantics. Is that okay? So this is all about syntax and what? Semantics. But listen, I forgot something. The EBNF, though easier to read and write, may be more demanding in processing, machine processing. Because the example we gave, you can see that it's not like, there's a minus there. and he's putting tape first. And you know that x minus y is not the same thing as y minus x. I hope you know. So the issue commutativity. Thank you for helping me. The issue of commutativity is not being addressed by EBNF, but there's a way out. During processing, they do the passer is able to understand. Are you okay? But that's a disadvantage of EBNF. So the BNF describes better, correct, but then describes more accurately than EBNF. But the BNF describes more precisely and concisely. The EBNF describes more precisely and concisely than the BNF. Are you okay? It has that disadvantage. The context-free grammar is also more, not as precise or concise as BNF, and it's not machine processable like BNF because of the use of angular bracket. Of course, we know that the natural language, use of English and natural language is verbose is out. So that is how this is what we will do today. Any question? The next 10 minutes question. Yes. Sit down. Yeah, you know, no, it's not that it will be slow. It's the issue I want to raise. The issue of commutativity is a very serious issue, because when you balance it, it will now not be able to know or maintain commutativity. Outside that, there's no problem. By my little experience. So the S, it will now invoke another procedure for it to be processed, so it will be correct. I've forgotten it. Is that okay? Another procedure will be invoked. Hence, it's more demanding now. I did not say it's less efficient. I say it's more demanding. It means it will require something else to rectify that. I cannot say. But what I can say is that it can be more demanding in machine processing than what the BNF. That is all I can say. The whole word, that's what I can say. Any other question? My attendance. Any other question? Yes.
And what's the use of this EBNF in today's world?
Okay, I've told that it's not how I started. So what is the use of BNF, EBNF, or processing in today's world? I think I should ask you.
I don't know.
But that's how I started now. I said it's to satisfy three stakeholders: the evaluators, the implementers, and the U programmers, so that they can evaluate accurately, implementers can implement correctly, and the users can use efficiently and correctly too. Without these things, the problem is we are not in the forefront. I ask a question, a critical question. When a new programming language comes into being, who writes the compiler? Who writes the interpreter? What do they use? Take note, most time it is not those that design the language that write the compiler. That's why you have many compilers. You understand now? So what do they use to write the compiler? It is this language representation. When the language is being designed, to check whether what you are doing is right or will be right, is correct, the language evaluator is this representation. Asking me the same question is like asking me of what use is language in modern time. Communication. But this communication is not for every Dick and Harry. It's for these set of people. Evaluators, implementers, and users. And those are the people that the programming language is meant for. It's not meant for my mother now. That is, you can have, you are learning computer now. You must pass English language. Get a minimum of C6 to be able to read it. Is it English language you came to read? So the essence is for communication among stakeholders, which I have mentioned. That's how I started now as a motivation. You came late and you are disturbing me. A last question. No question from the back. They are the non-academic students. So we end the class.
Thank you, sir.